The SQL ordered by executions section of an Oracle AWR report lists SQL statements based on the number of executions. It also represents the number of rows fetched/processed. Executions. This column shows the number of times each SQL statement was executed during the specified snapshot interval. Rows processed. This column represents the total number of rows processed by each SQL statement during the snapshot interval. Rows per exec. The rows per exec column calculates the average number of rows processed per execution. It is obtained by dividing the total rows processed by the number of executions. Elapsed time. This column indicates the total elapsed time spent executing each SQL statement during the snapshot interval. %CPU. The %CPU column shows the percentage of CPU time consumed by each SQL statement in relation to the total CPU time used by all the SQLs. %IO. The %IO column indicates the percentage of IO time consumed by each SQL statement in relation to the total IO time used by all the SQLs. The SQL statement with the highest number of executions was executed 7,326,627 times, is the most frequently executed statement and is highly CPU intensive, about 101.7%. However, it processes a relatively low number of rows per execution, average of 1.00 row per execution. With an elapsed time, 154.96 seconds, the SQL statements do not appear to consume significant I/O time, as the values are close to 0%. The SQL statements executed 102,711 times, while not CPU intensive, involve processing a significant number of rows per execution. They also take up less elapsed time. The SQL statement executed 58,499 times is both CPU and I/O intensive, processing a moderate number of rows per execution. It's important to evaluate SQL statements based on their execution frequency, resource consumption, CPU and I/O, and efficiency, rows processed per execution. More analysis may be required to determine whether these SQL statements need optimization or if the resource usage aligns with their intended purpose in the application. The SQL ordered by Parse Calls section of an Oracle AWR report lists SQL statements based on the number of parse calls. Parse calls occur when the database parses a SQL statement, meaning it processes the statement and generates an execution plan for it. Parse calls. This column shows the total number of times each SQL statement was parsed during the specified snapshot interval. Parse calls occur when Oracle processes and optimizes a SQL statement for execution. Executions. This column represents the total number of executions for each SQL statement during the snapshot interval. An execution may involve running a previously parsed SQL statement. Total parses. This column shows the percentage of total parse calls that each SQL statement's parse calls represent in this section. It's calculated as a percentage of the total parse calls for all SQL statements in this section. The SQL statements in this data make up varying percentages of the total parse calls, ranging from 1.16% to 8.95%. The SQL statements with 102,711 parse calls and 102,711 executions indicate a high level of activity. This suggests that the SQL statements are being frequently executed and parsed, which could be a potential performance concern. It's important to examine why these statements require frequent parsing and whether they can be optimized or if they are expected to have high parse call rates. Most of SQL statements are also indicating a 1-to-1 ratio between parse calls and executions, indicating that it is consistently executed. Other SQL statements have lower percentages of the total parse calls but should still be reviewed to understand why they are frequently parsed and executed. More analysis is needed to determine the reasons behind frequent parsing and whether optimization or caching strategies can be applied to reduce the parsing overhead and improve overall database performance. The SQL ordered by Sharable Memory section of an Oracle AWR report lists SQL statements based on the amount of shareable memory used by the SQL statement in the shared pool. Sharable Memory is the memory area in Oracle's shared pool that stores parse SQL and PL/SQL code, making it available for reuse by multiple sessions. Sharable MEM. This column represents the amount of shareable memory used by each SQL statement in bytes. Executions, this column indicates the total number of executions for each SQL statement during the snapshot interval. %total, this column shows the percentage of the total shareable memory used by each SQL statement in this section, relative to the total shareable memory used by all SQL statements in this section. The SQL statements in this section have relatively low numbers of executions, indicating that they may not be frequently run. However, they consume shareable memory in the shared pool. The SQL statement with the highest shareable memory used is 30,687,328 bytes. Most of the listed SQL statements have low numbers of executions, one or a few executions. The listed SQL statements contribute varying percentages of the total shareable memory used, with the highest being 0.19%. SQL statements consuming a large amount of shareable memory may be complex queries or PL/SQL blocks. The high shareable memory usage suggests that they involve extensive parsing and execution plans. While the percentages of total shareable memory used by these statements are relatively low, it's important to monitor them, as excessive memory usage in the shared pool can lead to inefficient memory management and performance issues in the database. In many cases, such SQL statements may be related to data pump worker or data pump master processes, which are typically used for data import and export operations. Monitoring the shared pool memory usage over time is important to ensure it doesn't become a performance bottleneck. The SQL ordered by version count section of an Oracle AWR report lists SQL statements based on the number of versions generated for those statements. Versions are created when DML, data manipulation language, operations are performed on rows in Oracle, and they are tracked for maintaining read consistency. The version count can be an indicator of how actively certain tables or rows are being modified in the database. And this information can be used to fine-tune application code or database design. Version count, this column indicates the number of versions generated by each SQL statement. Each time a row is updated or deleted, Oracle creates a new version of the row. This column counts the total number of versions generated by the SQL statement. Executions, this column indicates the total number of executions for each SQL statement during the snapshot interval. An execution refers to running a previously parsed SQL statement. Most of the listed SQL statements have low numbers of executions, typically one or a few executions. The SQL statements in this section have generated different numbers of versions. The version count is an important metric to monitor because high version counts can have an impact on the database's undo and redo behavior. The SQL statement with the highest version count is 84. A high version count typically suggests that the SQL statement is involved in frequent DML operations, such as updates or deletes, on rows within the database. It's essential to monitor and investigate SQL statements with high version counts to ensure that they are optimized for performance and that there are no performance bottlenecks related to undo and redo management. Analysis is required to understand why these SQL statements have generated a significant number of versions and whether there are opportunities for performance optimization or reduced impact on undo/redo management.